All right, January 2019, question 10a. It says three matrices are given as follows: P, Q, and R, as indicated. Where to I, using a calculation to support your answer, determine whether matrix P is a singular or non-singular matrix. So first of all, the matrix P is minus 1, 2, 0, 5. Now, in order for us to determine if a matrix is singular or non-singular, we have to first find the determinant. Now, if the determinant of a matrix, if the determinant of a matrix is 0, we say that the matrix is singular. Now, if the determinant is not equal to 0, the matrix is non-singular or is a non-singular matrix. So let's find the determinant. The determinant of P would be minus 1 times 5, leading diagonal, minus 2 times 0. So the determinant here, this would be minus 5 minus 0, which is still minus 5. Now, since the determinant of P, which is what? The determinant of P, which is minus 5, is not clearly not 0. Therefore, P is a non-singular matrix. All right. All right. So the determinant for a matrix to be singular, its determinant has to be 0. If the determinant is not 0, we say that the matrix is a non-singular matrix. So the matrix P is a non-singular matrix. II says, given that PQ is equal to R, we're to determine values of what? A and B. All right, so the first thing is that we're going to have to solve a matrix equation. The matrix equation is PQ is equal to R. Let us solve that matrix equation. All right, how do we go about solving this? Now, to solve a matrix equation of this form, essentially what you have to do is that you have to write back Q, which is the unknown, and multiply the right-hand side of the equation by P inverse. So this is P inverse R. All right, where's all of that coming from? I'll just do something to the right to show you where it's coming from. QP is equal to R. Now, first of all, if I multiply both sides by P inverse, I'm going to have P inverse R. Now, P times P inverse, if you multiply a matrix and its inverse, you're going to get the I matrix. So IQ is equal to P inverse R. Now, if you multiply a matrix by the identity matrix, you're going to get back the matrix itself. So Q, which is my unknown matrix, is equal to P inverse R. Now, since I know that this is going to happen anytime I go about solving this, I can just bypass these steps there. All right, and say that if I'm solving a matrix equation of the form PQ is equal to R, I just write back Q on the left hand side and multiply the right hand side where R is by P inverse. So to solve, therefore, the first thing I have to do is find P inverse. Now, P inverse is equal to 1 over the determinant of P times adjoint P. All right, we just found the determinant of P. So this is minus 1 over 5 times adjoint P. Now, P, if you remember, is the matrix minus 1, 2, 0, 5. So adjoint P would, you're going to switch around the leading diagonal elements. So this is 5 here, minus 1, you switch them around. The other two elements stay where they are, but their signs change to minus 2 and 0. If you change the sign of 0, it's still 0. Alright, so this is P inverse. So therefore, the solution of my matrix equation is Q, which is A, B, is equal to P inverse, which is minus 1 over 5, 5, 0, minus 2, minus 1, multiplied by R, which is 11, 15. Alright, so let's deal with the matrices first. Multiply the matrices first and then come back to the fraction. So this is 1 over 5. Row by a column, first element in the row, first element in the column. So this is 5 times 11, which is 55. Second element in the row, minus 2, times second element in the column, which is 15. So it's minus 2 times 15, which is minus 30. Bottom row, 0 times 11 is 0, minus 1 times 15 is, so this is 0 minus 15. So what we have here is minus 1 over 5. And up here we're going to have 25. And down by the bottom we have minus 15. So we're going to multiply both elements by 1 over 5. Multiplying by 1 over 5 is the same as dividing by 5. So the matrix Q would be equal to minus 25 over 5. And a negative times a negative is a positive. So it's, alright, let's put minus 15 minus, sorry, better. A negative times a negative is a positive. A negative times a negative is a positive. So it's positive 15 over 5. And this is A, B, which is Q. Therefore, I can say that AB, matrix AB, or the matrix Q with elements AB, would be equal to minus 5, and down by the bottom we have 3. Now, two matrices are equal if they're of the same order and corresponding, and all the elements are equal. Two matrices are equal if all the elements are equal. So therefore, A must be equal to minus 5 and B must be equal to 3. A is minus 5 and B is 3. Alright, there's one more part of this question. It says state the reason why the matrix product QP is not possible. Alright, first of all, Q is a 2 by 1 matrix. So Q, which is the matrix AB, has 2 rows and 1 column. So Q is a 2 by 1 matrix. Now P is a 2 by 2 matrix. So if I multiply Q by P, I'd be multiplying a 2 by 1 matrix by a 2 by 2 matrix. Now, comparing them side by side like this, I can see immediately they're not compatible. So this is row, and this is column, and this is row, and this is column, the order of the matrix. Now, two matrices, so I have a slight error here. Over here we have QR, it should have been QP. Now, two matrices are compatible for multiplication when the number of columns in the first matrix, here 1, is the same as the number of rows in the second matrix, here it's 2. So obviously they are not the same. So because these two values are not the same, QP QP is not compatible for multiplication, and then therefore, so I could say QP is not possible because um, number of columns in the first matrix Q is not the same as the number of rows in the second matrix P. Therefore, um, QP is not compatible. Not compatible for multiplication. All right, that's a mouthful. All right, but essentially, um, two matrices are compatible for multiplication when the number of columns in the first matrix is the same as the number of rows in the second matrix. These two are not the same. Um, the number of columns in the first matrix is 1, the number of rows in the second matrix is 2, so they're not compatible. You can't multiply them together. Or the matrix product QP is not possible.